So to explain this, we can explain how we actually rewrote our graphics objects to be, not rewrote, but tweaked them to work better for the new containers. So a huge problem we had before was there's no way to control the engine memory that the user requests. So what we actually ended up doing is you take your graphics object and instead make it only consist of the iterator, which again, the iterator is just a pointer to data. So now the graphics object that the user actually owns and can put wherever they want in memory is nothing but a pointer to the relevant memory. So when you create your object in the constructor, he will then go and fetch the memory that he needs. Then anytime the user does like set color, all he's doing is getting that memory and setting the relevant data in there. So now the user doesn't own any of that memory. All the graphics data memory all exists in the array with all the others. So we found this is much nicer, and also it allows us in the future to recontextualize a graphics object. If you created just a series of different specialized constructors that had different information, just grab different data. And as long as all of those data objects can all handle the same functions, just basically through a strategy pattern, now you can completely retcon what a graphics object is purely by swapping the underlying data. So it's a nice little component pattern of sorts. Component pattern, strategy pattern, it's a little weird here. So when you actually go into the data, this is where all that awfulness graphics lives. This is where you actually get the pooled. Also, the double buffers are using that same system, so you'll see him again here. So we have this nice little, this is also another layer. So the graphics object has a pointer to data, who also has a pointer to the necessary double buffers. So creating this layer allows our threads to run in 3 different highways. The user runs through graphics objects, rendering frame runs through the graphics object data, and synchronized thread runs through the double buffers. So it's split into 3 layers, all using the exact same idea. But so now this graphics object data color is stored in the graphics object data color manager using the resource pool. So now all the memory for all of our graphics object data color all lives in an array. And now you can create the pool and the doubly linked list for that relevant memory, all using the same objects, or the same memory. So the resource pool you saw before. Oh, no, sorry. When you actually want to go get them, you say datapool.acquire resource. When you're done with it, you say datapool.release resource. And then to actually push them in there, you just push it back. Anytime you register for draw, you just push it back by passing that same iterator around. Then when you go to render, you just set your current iterator. All the managers also have an iterator, just to be nice, to the front of whatever your P head is in this case. And then while you still have nodes, render the current object that you're pointing to, and then go to the next one. So again, best case scenario, this would walk down the whole array. Otherwise, you're just jumping all over the array, which is not that bad. And so now we've done this for all of our graphics objects. They all look almost identical. They all are basically identical. Which it allows us to do is create this graphics data manager who owns all the managers who then all own arrays of all their data. So when you actually go to render, you're just jumping down these 5 arrays. You go to the color array, the color light array, sprite array, texture light array. So it's a really nice way of jumping only through arrays instead of all over memory. I believe that covers it for the graphics objects rewrite. You'll see a bunch of work for DX11 versus DX12. We're probably going to refine this system a bit more next quarter. Next quarter, we're probably going to entirely drop support for DX11 because this is supporting both is becoming really ugly really fast. Because you get grossness like this where it's just a lot of duplicate functions. So that's why you'll see some code in here that looks unused because we are trying to figure out the best way of handling that split. And again, that's mostly on Emmeline's side, so I'm certain they'll talk about that more.